Alright guys, we're going to be taking a look at your Chapter 7 practice test. Here's question 1. A phone-in poll conducted by a newspaper reported that 73% of those who called in liked business tycoon Donald Trump. So I can assure you that this test question was made long before Donald Trump became President Donald Trump. I think you know my feelings on that. An unknown true percentage of American citizens who like Donald Trump is, we have a choice between statistic, sample, parameter, population, and none of the above. So the idea here is that since we're talking about the true percentage of all American citizens, that sounds like we're talking about the population, basically, the larger set of people from which we are sampling. So because this is a larger set of people that we're sampling from, the correct answer here is a parameter. So the number, this is from the larger set from which we're sampling. Okay, let's take a look at question 2 as well. Question 2, we've got a sampling distribution of a statistic. So we have the sampling distribution of a statistic is a probability that we obtain a statistic in repeated samples. So no, that is not correct. A sampling distribution has nothing to do with probability. So probability makes this not true. The mechanism that determines whether randomization was effective, again, this sounds really good, but it is not correct because we don't use a sampling distribution to tell whether or not randomization was effective. So that's not true. The distributions of values taken on by a statistic in all possible samples of the same sample size and from the same population. So this is actually the correct answer. That's definition. We're taking a look at any statistic from a population, and we're looking at every possible value of that statistic. I got to remind you again that the sampling distribution is not something that you actually compute. You don't ever get the number there. You just use it or you use known values or supposed values to create a sampling distribution. And then you use it in kind of an argument. D, the extent to which sample results differ systematically from the truth. That is interesting because that's kind of what we're using the sampling distribution for, but is not actually the definition of a sampling distribution. And from the truth is kind of weird here because you don't actually know the truth. The process of statistics is not necessarily that you know the truth. It's just that if you imagined some value of the parameter is true, then how does that color your view of a statistic? So that's question 2, and we're going to look at question 3 as well. The number of undergraduates at Johns Hopkins University is approximately 2,000, while the number at Ohio State University is approximately 40,000. At both schools, a simple random sample of about 3% of the undergraduates is taken. The sampling variability is smallest at which school? So for this one, sampling variability is tied to sample size. So the bigger the sample, the smaller that variability is going to be. So if we do 3% of 2,000 here, that would be at Johns Hopkins. And Johns Hopkins, we've got n is equal to 3% of 2,000, which is, I don't know, 60 or 600. And if we take a look at, what is this, Ohio State? I think that's OSU. So the sample size N would be equal to 3% of 40,000. That is what, 12 with, I don't know, 2 zeros at the end there. So as we can see, the sample size at OSU is much larger. So the variability should be smallest at OSU. Okay, smallest at OSU. Okay, this kind of assumes that the statistic that you're getting is about the same. But if that's true, then of course OSU would be the correct answer here. I'm going to grab my calculator because I'm not sure that I did this multiplication right. So 3% of 2,000. Yeah. 3% of 2,000. Why is this calculator not working? Oh, apparently that's 6,000. So, no, 600, I'm sorry. No, it's 60. There we go, 60. And then that other one must be 40,000. Yeah, that's 1,200. So I did it right the first time. Okay, so that is questions 1, 2, and 3. We'll see you in a moment for 4, 5, and 6.